Okay, these routers are loud. Okay, they're 2800s, and it made me uh, literally bring the microphone very close to me so you can hear me. Uh, if the noise is too much, let me know. Then I'll have to relocate the routers somewhere else. But for now, okay, this is what we got. So, um, I am trying to set up my CSR 1000Vs, okay, in VirtualBox, which it was kind of weird. I had to actually look up a video to figure out how to do it, because it just it's been acting funny, and it's funny because there's whenever I find something that works, especially with the CSR 1000Vs, there was a lot of versions that didn't work. So when I found one that worked, it's been saved in my storage for years. Okay, and for some reason, VMware will not run these VMs. Okay, so I'm trying to do a VirtualBox. If it doesn't work, oh well. Okay, we only get to use live routers, which I'm okay with that. So, but having virtual routers like CSR 1000Vs are always nice. But as I'm looking at it now, it looks like it's steadily rebooting on its own. I've gotten to a command prompt with this, okay? Just when I add an interface, okay, and bridge it, it doesn't work, okay? And again, this is another reason why I don't use virtualization, okay, in a lot of ways, as far as doing my hardcore studying with Cisco. Yeah, and it just keeps on rebooting. So that's a bust. Oh well. Okay, so what is the purpose of a router? Okay, we already discussed that, to communicate between networks, right? But what we didn't talk about is to shorten broadcast domains. Now, if you look up Cisco best practices, okay, it'll give you an idea. Obviously, you have to be very specific though on what you're looking for, like how many routers in the broadcast domain. Cisco best practices, something like that. Okay, it could be like 200 routers, maybe. And if you have to understand, because when a broadcast message goes out, it needs to go out to 200 routers. Okay, Cisco has a recommendation how many routers you should have in a broadcast domain. Okay, not only does that information goes out as a broadcast to everybody on that domain, okay, but it also does what? Okay, all right, it goes out as a broadcast, but they're all going to respond. Okay, all right. Now you got to understand, the way we were drawing a router was a router connected to a router, connected to a router, connected to a router. However, you can have multiple routers connected to a switch in the same broadcast domain. Okay? Alright? Remember, every router is its own entity. So I can have router 1, okay, connected to a switch with a 192.168.1.1 interface, and a second router connected to the same switch with a 192.168.1.2. Okay, it doesn't necessarily have to be a daisy chain type scenario. Okay, all right. Now, what does a router do with broadcast traffic? Okay, so here's the thing. Okay, a router will send out a broadcast. If it hits another router, okay, that other router will respond to that broadcast, okay, but it does not forward it. All right. Now you gotta understand, that means that your broadcast domain stops at the router interface. It does not go over to another interface of that router. So if I have 3 routers connected to a switch, okay, one of those routers are going to be connected to the switch. Now, if I have 2 interfaces connected to the switch, I can't have them in the same IP address. Okay, as far as a broadcast domain in the same broadcast domain, meaning I can't have two interfaces of the same router going to a switch, okay, and have 192.168.1.1 and 1.2. I can't do that. The router's not going to allow me. TCP IP is not going to allow me to do that, okay, whether I'm using a router engine on a switch or a router at all, okay? It's not going to allow it. So think of that for a second. Okay, now if I want to forward that broadcast message, okay, I will have to use something that's called an IP helper command. And what that's going to do is it's going to convert, okay, that broadcast traffic to a unicast traffic. Okay, all right. Now we discussed what those options were. You got broadcast, anycast, unicast. Okay, all right. Now, how do I put an IP address on an interface? It's the same thing we did with the VLAN interface. There's no difference. The iOS for a switch and a router are almost identical, okay, except the fact that you have router commands on a router and you have switch commands on a switch, okay? But the general concept, as far as the general show commands, they're the same. Show IP interface brief. So this is part of stuff that we do not have to relearn. Now, I have serial interfaces on both these routers, but we're only going to use the fast Ethernet interfaces, okay? And this is a module, okay? So if I do a show inventory, as you can see, I have a 8-port serial module, okay? NM/8AS. That is network module 8. I think it's asynchronous serial. I can't really remember what the 8 stands for, but I think it's what it stands for. But nonetheless, look it up. Okay. So now, since we're not using them, we're not going to be discussing serial interfaces. Okay. Not that you're never going to run across them. It's just a concept that it's just something that we're not going to teach because most likely you're going to be dealing with Ethernet interfaces. Okay? Alright? So, what layer does a router use to direct traffic? Okay, that would be layer 3. Alright? Okay, the whole time that we've been doing things, we've been doing it on layer 2. Okay? And you gotta understand, layer 1 is the physical. Okay? Built on top of that layer 1, we're going to use layer 2. Meaning that layer 1, if that's not working correctly, layer 2 is never going to work. And same thing with layer 3. We can't have layer 3 working if layer 2 is not solid and working properly. Okay, every layer going up the OSI model depends on the previous layer. Meaning that without layer 3 fully working, how am I ever going to have layer 4 traffic with port numbers? Okay, because if I can't get to the layer 3 aspect, the port numbers are pointless. They're not going to work. Alright, so we need that lower layer connectivity to be working properly. Okay, now, okay, how do we see what interfaces are on the router? Show IP interface brief, which we just did. What is the ping command? Okay, now, the ping, okay, is a command that when you use this command, you will say ping plus an IP address, which I will show you here. And I'm going to ping an IP address on the internet, which literally is, Google DNS server. Okay? I believe 8.8.8. It's 8.8.8 and 8.8.4.4. Okay. All right. So notice that I sent out a ping and I got a reply. Okay. That ping was 32 bytes in size. Okay. The time was 10 milliseconds. Okay. Now, come on. I hate that. I can't stand that. What is... Okay. A millisecond is a unit of time equal to 1,000th of a second. And what that tells you is that this was 10 milliseconds. Okay, that means that is 10 slash 1,000th of a second. Okay, all right, that means you would take a second and split it up into 1,000 time intervals, right? Okay, and it's 10 of them that it took to come back. All right, now who the hell knows where that Google server is sitting? Okay, it could be in my same town. Who knows? Okay, all right, it could be across the country. I don't know. All right, now look at this thing here. This says TTL. That is your time to live. Okay. Now, what happens when I send out a ping? I'm going to send out a ping request to 8.8.8.8. Okay? I'm going to set the time to live power to 255. Okay? And that request goes out. Now, okay? Now, when that 8.8.8.8 gets a ping request, all right, what's in that packet? Okay, the source IP address and the destination IP address. Okay, now 8.8.8.8 is going to respond, okay, with its own message, meaning that if I send out 4 pings, he's going to send back 4 ping requests. Okay, now he knows what the source IP address is because it's in my packet. Okay, my layer 3 information. Remember, you need source IP, destination IP, source MAC, destination MAC. All right, but it only cares about the source and destination IP. So it goes out and it puts 8.8.8.8 as the source and my IP address as the destination. Okay, and it responds to the 4 requests that I sent out. Okay, what this is now, you gotta understand, I send out a request. Okay, it sends out a reply. I kept saying request. I'm sorry that if I messed that up. Okay, I send out the request. 8.8.8.8 sends back a reply. That's why it says we got a reply from 8.8.8.8. Okay. Now, okay, it has a time to live of 119. Okay, that tells you that if it was set to 255, okay, we have 119. Sorry, we have 119 hops left. Now, what happens when our time to live hits 0? Well, that packet is dropped. Okay, that's why we don't need anything as far as a loop prevention, because our time to live is that loop prevention. Spanning tree is needed on a layer 2 because layer 2 does not have any loop prevention. Okay? Alright? Now, in our TCP stack with our protocol, we can determine what that is. Like if I'm using a routing protocol that or any type of protocol that needs to be directly connected, it's going to send its time to live to 2, okay, or 1. All right. So when the other router gets it, okay, all right, it's going to mark it to 0 if it gets routed. Okay. So when the next router gets it down the line, right? Which would not be one hop next to it, right? It'll be two hops down the road. That second router is going to kill it. Okay? All right? So now, all right, that's our ping. Now, you got to understand now, when I ping out and I get replies back, what I am getting is two-way communication. That means my packet, my ping, got to the destination and the destination got back to me. So, from my perspective, okay, there's a good chance that if I'm going to use TCP/IP, okay, or I'm sorry, TCP traffic, which, you know, we haven't discussed that yet. If I'm going to use traffic that needs to have two-way communication, testing it with a ping, most likely I'm going to have that successful. Now, don't get it twisted, okay? Ping is not your ultimate tool to test communication, all right? My pings can be successful, but my traffic could be denied on a different level, okay? Matter of fact, I could allow pings and deny everything else. All right? I mean, why not? I mean, it's my firewall, okay? All right? Okay, so we talked about how many interfaces could be on the same network. That's one, okay? All right? Per router, all right? Using CDP to see connection devices, including Cisco voice phones. I don't have any Cisco phones, so actually I do. Okay, I could pull one out of the garage, but it's not necessary. Okay, all right. So, okay, so nothing. All right, but we know what this does because you saw me do it on the switches. Okay, so nonetheless, all right. Now, this information here is for serial connectors, so we don't need to worry about that, okay? All right? How did we mess that up? Here we go. Okay? All right? Okay, so, all right, this you need to do your own research, okay? All right, but, you know, you can have different types of lines coming into your company's data center or closet or DMOC, whatever you want to call it, okay? All right? But again, we're not going to talk about T1s, E3s, OC lines, or none of that stuff, or ISDN, okay, a frame relay or MPLS. That's for your own research, okay? All right? Depending on what company you work with, most likely they're going to have an MPLS circuit, okay? They might have an OC circuit. They might have a fiber ring. Who knows, okay? Now, our interface status, okay? Remember, that a switch's first interface is F01 or G01, okay, or 10, right? For 10, you know, for 10 gigabit, all right, doesn't really matter, all right. Now, with a router, the first interface on the board is always going to be 0/0. That's always going to be your first interface. Now, PC always uses 0 as the first of anything. Okay? Alright? So, on a router, you'll see FA00. If you log into a switch and you're doing an FA00, 9 times out of 10, it's a router. Okay? Alright? So, just giving you that information there. Alright? Administratively down. Anytime you see this, that is someone who physically went in and shut down the interface. Okay? Now, how do I bring back the line when my text interferes with what I'm typing? The tab key. Okay, on your keyboard. Just hit tab. Alright? Because if you don't learn that trick, you're going to have logging synchronous turned on the console, which we're going to do right now anyway. Okay. Now, watch this. Interface shut and show IP interface. See, now I got login synchronous. It does not interfere with my text. Okay. So no shut. Show IP interface brief. See? Okay. So that problem's fixed. All right. So now we're gonna actually go into here and do one more thing. Line console 0 and no exact timeout. Alright, do show history. Now there's two histories. Okay, one is config T and one is privilege exec mode. Okay, so you have to be in privilege exec mode to know what the history is for that. Show history. Okay, all right, and if you're in config T, all right, see, there's only one. There are different histories, and you have to be in those modes to get those histories. Okay, so just just a little tip there. All right, and no exact timeout. Okay, and go ahead and write the config, which is WR to write the config, or the whole command copy running config starter config. All right, same thing. Okay, so now FA00 status is up. Okay, now in order to get my protocol up, I got to have a cable going from one to the other. Okay, now I'm going to take a crossover cable because I'm going from a router to a router. Okay, all right, router to switch will be a straight through cable. Okay, and we are going to plug in FA00 to FA00. Okay, now that's not going to work because this one needs to be no shut either as well. Okay. All right, and I don't have any lights, so let's try this crossover cable. Okay, I don't have any lights either, so let's. So what I'm going to do is I'm going to plug one of this into a switch and see what I get. Okay. Alright. That's obviously not going to work because it's a crossover cable. What is going on here? It is definitely a crossover cable. So why are we not working here? Okay. Let's try this. Boy, I'm having some weird problems with these devices. I mean, like... Okay, so that came up by plugging it, a straight cable into a network card. Okay. And using a straight through cable from FA00. That is just weird. Okay, and you know what? I'm not even trying to figure it out. Alright. Okay. All right, so that cable made me into a liar, but that's not right. That's incorrect. Okay, going from a router to a router, the pinouts are the same, so you need a crossover cable. Okay, for some reason the crossover cable going from router to router didn't work. I don't really care. The straight through cable worked. Hey, okay, it is what it is. But now you see our status is up and our protocol is up. Okay, now your protocol can't be up if there's not a cable connected to those interfaces and it's not up, meaning that you did not have a no shutdown. Only then, when you have up and up status on both interfaces, can you actually communicate with each router. Okay? Now, we're going to actually call this router 1. Router 2. We're going to go into FA00. IP, matter of fact, let's kind of switch these. Come on. Alright, we can bring it down here. Interface FA00, IP address 192.168.1.1, 255, 255, 255.0. Okay? And now we're going to try to ping 192.168.1.2, okay, which is going to be the IP address of this router over here, router 2. All right, but I have to do a question mark. I'm going to actually use the repeat command, okay, and we'll do it for 100 times. All right, now IP address 192.168.1.2, 255, 255, 255.0. And notice our ping is completed. Very quickly too, by the way. Alright? So now, understand that every router and every switch has a packet per second. Okay? Alright? And you'll be able to see those. Okay? And kilobits per second. Okay? As data is going through. Alright? So now, alright? That's your bandwidth though. Okay? Our input, here we go. Our bits per second. Okay? So now, let's redo this command and let's repeat it 10,000 times. Okay? And now, let's take a look at show interface again. Okay? Now, we are doing 2,000 bits per second. Okay? Alright? Close this. Now, keep in mind that this is a 5-minute input rate. Okay? Alright? Now, now this is going to be... Alright, I can already feel me losing this command, missing this command already. Alright, it's just question mark. Let's see what we can get. I'm gonna have to look it up. IP. Yeah, I don't recall. Yeah, I've literally forgotten this command, so I'm gonna try again. You know what? I think I just remembered it. Load interval, okay, 30. Hey, I'm proud of myself. Okay. All right. So now, show interface FA00. Okay, and now that input is no longer 5 minutes, it's at 30 seconds. Okay, alright? And as you can see, I don't, you know, we gotten this bits per second, okay, but technically it's 10 packets per second. All right, so it must still be talking, or else there it goes. It's starting to drop. Now it's 5,000 bits, 3,000 bits, okay, 2,000 bits. Now what's happening is the queue, the input queue, is it's getting empty, okay. All right, and there we're back to 0. Okay, so there you go. All right, now, that's pretty much it for this video. When we come back, we're going to talk about static routing and go from there. Okay, so remember to be strong, be determined, be successful.